Why, hello there, lovely one. So we're going to look at the concept of gradient, more specifically the first derivative using calculus, and how it relates to different functions. And I've taken these questions from the Mind Action Series textbook, the 2019 version. It's chapter 4, exercise 5, and it's just a couple of the questions. So the first one, determine the gradient of the tangent to the graph, and they've given us the graph at x is equals to 1. Step 1, we need to find the first derivative, and of course this is quite nice and easy because we take the exponent, we multiply the coefficient by it, and of course that's 1x to the power of 1, so that means we're just left over with 1. The question is asking us for the gradient where x is equals to 1. So we're going to substitute 1 in for the value of x for this question, and that gives us 3. And that is the gradient of the graph at where x is equals to 1. Question B1 asks us to find the equation of the tangent. And remember, when we're finding an equation of a tangent, it's a straight line. So we're looking for y is equals to mx plus c, where m is the gradient, and c is going to be the y-intercept. So it's pulling from your knowledge from grade 9, when you learned about straight lines, well, I suppose even grade 8. But anyway, we're given the function, so let's start by finding the gradient of that function at that particular point, which means I've first got to find the first derivative, and that's going to be negative 2x to the power of 1, and it's going to be plus 5, and I'm told that we want it where x is equals to 3, so we substitute that in 3, and remember that you do have a calculator to do this calculation for you. We make silly mistakes when we're under pressure. So that means our gradient at that point is going to be negative 1. In order to find the y-intercept, we're going to need to have some kind of point to work from. And of course we know the tangent is connected to the function at one particular point, and we know that that point is where x is equals to 3. So let's substitute the value of 3 into the original function so that we can figure out what the other part of the ordered pair is. Once again, you have a calculator, so that should be 6. Meaning that the coordinate we're going to use, or the ordered pair, or whatever you want to call it, is 3 and negative 6. So at this point in our formula of y equals mx plus c, we know that the gradient is going to be negative 1, so negative x plus c. We're now going to substitute the point 3 and 6 so that we can discover what c is, and then we're going to, well, solve for it, and we should get that c is equals to 9. That means that the gradient of the tangent to the function where x is equals to 3 is y is equals to minus x plus 9. Question B2 asks us to determine the equation of the tangent to the graph, and it gives us the function and the value x is equals to negative 2. Now whenever we've got x in the denominator, we need to change that, so before we find the derivative at least. So we know that it's going to be negative 12x to the power of negative 1. And once we found the derivative, we're going to do negative 12 times negative 1 gives us 12, and then we've got x to the negative 2. They're wanting to know where x is equals to negative 2, so let's start by substituting that in. And remember, you do have a calculator that will do this for you. And it should give you an answer of 3. So that means the gradient of the tangent at this point is 3. And of course, we have an equation of a straight line. We know what the gradient is now. We need to figure out what c is, and the way we're going to do that is substitute negative 2 into the original function, because that will tell us, whoopsie, let's just erase that x, and we'll substitute in the negative 2, and that will tell us the y-coordinate at that point. So our ordered pair is negative 2 and 6. Once we've got that, we can substitute that value into the equation that's busy developing. So subs. Remember, you've always got to tell the marker what you're doing. We're clever, but we can't read minds, so you have to constantly say things like substitute and have an order to your calculations. Okay, so that should mean that c is equals to 12. Our final equation of our line is y is equals to 3x plus 12. Question C of Chapter 4, Exercise 5, asks us to calculate coordinates of the point of contact between the tangent and the graph where tangent has a gradient of 5. So we know as soon as we start talking about tangents, we need to start thinking about our first derivatives. And so I'm just quickly finding the first derivative, and there we go. And I did that by doing 2 times by 2, it's going to give me 4, and then 2 minus 1 gives me 1. And that's where that came from. We know that the gradient of the line at that point is equals to 5, and so we need to solve for x, and we find out that x is equals to 2. Now what that means is the point of contact between the function and the line that has a gradient of 5 is where x is equals to 2. So let's find out what the other side of that ordered pair is. In other words, we're looking for what the y value is at the point where x is equals to 2. Once again, remember you have a calculator that can do this for you, and you should get the answer of 2, giving us a coordinate of that. I could go on further and calculate the equation of the tangent at that point, but they've just asked for the coordinates of the point of contact, and that is what I've calculated. So let's just put a little arrow to indicate that that's the answer. Question F1 is a nice combination of skills that you've done before. You'll see that they talk about parallel to the line, and then they've given us the equation of a straight line. And they're wanting the equation of a tangent to the graph that's over there. Now remember, we're always looking for the gradient of the graph. And if they tell us that this tangent is parallel to that other line, it means that our tangent has a gradient of 8. How does that help us? Well, how do we find the tangent of any, well, the gradient of any tangent to a function? We've got to find the first derivative. So we first find it. We know that 8 is equals to negative 4x, which means x is going to be equal to negative 2. So that tells us the point at which the two graphs meet, or the point where the tangent and the graph make contact. We still need to figure out what the y-coordinate at that point is, and the best way to do that is to substitute x is equals to negative 2 into the original function and discover what it is that way. So our coordinate then is negative 2 and negative 3. Moving on to the side, the reason that's important is because we can use it to figure out what our C value is. Once again, remember, your marker cannot read your mind, so you must continuously be writing down and explaining what you're doing. Leave lots of space between lines and things like that so that it's easier for them to find the answer. So once we've got the value of C, we just substitute it all back in, or all the information. I put a little arrow underneath there so that it is easier to see. There we go. I love question H because it's got a whole lot of weirdly buried information, and they're wanting us to discover what the values of A and B are. They've given us the gradient of the tangent at a point, and they've given us the point where that tangent is. We're finding two different variables, which means we're going to use simultaneous equations. We've got to develop two equations because of the two variables and use them simultaneously to solve. Now, because we're talking about a gradient of a tangent, you've always got to think of determining the first derivative. So that's what I'm doing now. I'm throwing in the values so that I've got the first derivative of that function. The reason why that's useful is I know the gradient of that function, so I know it's going to be equal to negative 3 at that point. And I also know that the x value at that point is 2, so let's throw in a 2 over there, which leaves me with negative 3 is equals to 4a plus b, and if I want to make b the subject of the formula, which is easier in my opinion, in this case, it's going to be minus 3a, well, minus 3 minus 4a. So now we're going to use that to figure out what b is. The way I'm going to do that is substitute b is equals to negative 3 minus 4a into this other equation. The reason I'm telling you this is because you can't read my mind. I need to write down what I'm doing so that my marker understands that I understand what I'm doing. So instead of writing a b, I'm going to minus 3a, well, minus 3 minus 4a, then x plus 3, and I'll multiply it out so that I get x squared plus minus 3x minus 4ax plus 3. So now that we've got there, I'm going to substitute the point in that we've been given, which is 2 and 5. And once I've done that, you'll see that the only variable I'm left with to calculate is going to be, well, that shouldn't be plus, should be minus 3 and a value of 2. The only variable that should be left will be a. So there we go. Now I'm just going to simplify quickly. And this gives an answer of a is equals to negative 2. Now that I've got that, let's just move up a little. I'm going to substitute. Once again, I'm telling my marker what I'm doing. A is equals to negative 2 into, and it feels like a waste of time, but you possibly will get marks for writing things like that down. Possibly. Maybe not. Maybe you will. I don't know. So that means I've got b is equals to negative 3 plus 8, which means b is equals to 5. You should use your calculator for that. I didn't, but you should. Okay, so our two answers are a is equals to negative 2 and b is equals to 5. If you really want to make life easy for your marker, which you really do, at the bottom, just write very quickly that a is equals to negative 2 and b is equals to 5. It means they don't have to go searching for it. Question I is another really good question to put in a test or an exam. It's talking about the equation of a tangent to a function. So the first thing you've got to be thinking about is finding that first derivative. Then it's telling us where the equation of the tangent, it meets at x is equals to 3, and it has a value of that, or the straight line does. So let's start by finding the first derivative of the original function. And I know, once again, I know I need to do that because we're talking about the equation of a tangent at a point. We're told that at that point, x has a value of 3, and we also know that the equation of the tangent, the gradient, is 15. So once again, because we're solving for two variables, it means we need to use simultaneous equations. So I'm going to rearrange this beautiful equation. First, I'm simplifying it so that q is the subject of the formula, because in my mind that's just easier to do that way. And now that I've done that, I'm going to be a little lazy here and label it number 1. And I am going to substitute that. So I say subs 1 into, and it's the original equation I'm going to use, so I'll just write y is equals to p x squared plus qx, and that gives us y is equals to px squared plus, and instead of q, we write the 15 minus 6p gives us x, and if I simplify it, it's px squared plus 15x minus 6px. But you see, now we have a problem. We've got this over here, but we only have a value for x that we can substitute in. In other words, let me just show you what I mean. I'll do it in a different color. We're told that x has a value of 3 at this point, so let's go 3x squared plus 15 times by 3 minus 6p times by 3. But in order to solve for one variable, we can only have one variable in the equation. At this point, we have 2. So we need to figure out what y equals at that point. So let's go off to the side. And let's remember the fact that we've got the equation for a straight line. And we also know, sorry, minus 18, we also know that x is equals to 3 at the point of contact, so I'm going to substitute it in 15 times by 3 minus 18, and remember you have a calculator, which should give you the answer of 27. So we have a coordinate of 3 and 27. So coming back down to this over here, I'm going to erase what we did previously, and I'm going to tell the marker that I'm substituting the point 3 and 27 into this equation so that I can then solve for p. And that gives me an answer of p is equals to 2. So I am going to take that value and I'm going to substitute it into equation 1, where q was equals to 15 minus 6 times by p, and once again you have a calculator so that you would get an answer of 3. Therefore, our values are p is equals to 2 and q is equals to 3. The reason why I rewrite them underneath is so that my marker can find them easily. That's all from me for now. Much love.